Hello everyone, and welcome to the Unit 6 system review for the test. So what we're going to be going over here is there were some typos. Hopefully we caught them all. The first typo we found was right here in the equation for this line. Hopefully that didn't confuse you. You should be able to find the equation of the line anyway. So what we're asking in this is the basic understanding of what a systems of equation is. So for A, here, we're saying, hey, what is the intersection of this line and this line? Well, it's going to be right here. So there's one solution. That solution is 2, 2. For number 2, y equals x and negative x plus 0 equals 0. And what you will see is that that is actually the same line. So there are infinite solutions. For C, we're once again doing y equals x, and now x plus 4 equals y. Well, if that's actually, this is the same problem here, and you'd have to figure that out. But if you solve that for y, you would get that problem right there. And so that, once again, is one solution, and it's 2, 2. It's important to remember there's several different ways in which we can write the equation for a line. And just going through for the rest of this, D, once again, is y equals negative x plus 4 and x plus 4 equals 4. Well, that's this equation twice. So that means there are infinite solutions. And then for these last two, the answers are 1, because negative x plus 4 and x plus 3 intersect right there. And that solution is 3, 1. And then on this last one, y equals x plus 4, which is this line, and x equals 3. The intersection is right here, which is 1, 2, is the one intersection, and that is at 3, 7. So scrolling up, solve the system of equations any way you choose. Important to read the instructions. It didn't say you had to use the graphs. I'll go ahead and use the graphs for the first one, though, because they're both already in y equals mx plus b form. And so for the first one, the slope, the y-intercept is 2 and the slope is 1. And so I will get a line that looks like that. For the second equation, the y-intercept is negative 2 and the slope is negative 1. So I get a line that looks like that. And so they intersect at negative 2, 0. Or if you're used to writing it this way, that's fine as well, because they intersect right there. All right, for the second one, I'm solved for one variable, so I'm going to go ahead and use substitution. So that means that x plus 4x equals 6, or 5x equals 6. Divide both sides by 5, and I'll get x equals 6/5. And then to find y, I can just plug back in. Y equals 4 times x. So y equals 4 times 6/5, or y equals 24 over 5. For C, both equations are in what we refer to as standard form. So the easiest way to do this is I'm going to multiply the second equation by 3 so that the coefficients of x are additive opposites. Then I'm just going to add the two equations together. I'll end up with y equals negative 3. So then to find x, I plug my y value back in. 3x. Actually, I'm going to use the second equation, I think. What equation? I'll use the first equation. That's fine. 3x minus 5 times negative 3 equals 6. And I'm going to skip a few steps here, but you should end up with x equals negative 3. So if you like to write your solutions as a point of values, it would be negative 3, negative 3. For D, I'm going to go ahead and use substitution because once again, one of the equations is solved. So I'll get 4x plus 2 times negative 2x plus 1 equals 6, which is 4x minus 4x plus 2 equals 6, which means I write up this statement 2 equals 6. That is, all the variables are gone. That's not a true statement. So the answer is no solution. Let's keep right on going. So for this, it says use the calculator to find the solution. So let me bring the calculator up. Bring it on over here. Maybe. Here we go. Come on. You can do it. Oh, my calculator just went haywire. Doesn't like recording. Hold on, I'm going to have to restart. There we go. There we go. All right, so you want to do this in the calculator by using, so you would type, so I put in the first equation, y equals x plus 2. And then I put in the second equation, 3x minus 2. And then I graph them. And there are the two equations. Then we go to second, calc, intersect. First curve is the first line, second curve is the second line. Guess. You can do the guess, you don't have to. But you get the intersection is 2, 4. Whoa, I may have killed my computer here. For the second one, well, I don't know what happened there. I would need to rewrite the second equation as y equals negative 3x minus 4. And so let's go through the process again on the calculator. So bring the calculator up. And we put the two equations in. Y equals x plus 4 and y equals negative, always remember to use the negative key, negative 3x minus 4 we graph them, and then we find the point of intersection. And I get my intersection is at negative 2, 2. Now for number 3, it says use the calculator to find this. But right away I can see there's a problem. If I multiply the first top equation by 3, I get 3x plus 3y equals 12. These two equations are the same, so there are infinite solutions. For this one, if I rewrite the second equation and just write with the x first, you will see that that's the same equation as the top one, but it adds up to a different thing. So that is no solution. For E, once again, they want us to use the calculator. And if you wanted to solve these equations, you would get negative 3y equals negative 6x plus 27. Divide both sides by negative 3 and you get y equals 2x minus 9. And for the second equation, you would get negative 3y equals negative 2x plus 11. Divide the whole thing by negative 3. And I would get y equals 2/3 x minus 11/3. We can put that all in the calculator here. Let's make sure we get the right answer. So, no. So, whoops, I need to be able to see what I just wrote though. Y equals 2x minus 9. And y equals 2/3 x minus 11/3. Graph them. Find the point of intersection. And I get x equals 4, y equals negative 1. So I guess. All right, let's keep going. Graph the inequalities shown. Create a system of two inequalities that could be. So basically, one of these, we're going to drag these into here to get the inequalities. And so what we need to do is we need to look at the graph and figure out what the equation is. So for this one, the y-intercept is positive 4. And the slope is 3. So I know my equation is, oops, sorry, y, and then we'd have 3x plus 4. And if we look at it, we're shading down, so it's y is less than. Problem is none of the equations are written in that form. Oh, okay. So y, and it's a dotted line, so y is less than 3x plus 4. So there we go. 3x plus 4 is greater than y. The other equation, the slope, the y-intercept, is going to be y equals negative, is 1/3 x plus 1. But it's a solid line, and we're shading up from there, so it'd be that one. So it'd be that one. And then y is greater than, oops, sorry. Y is greater than or equal to negative 1/3 x plus 1. But then we need to erase all this, maybe, if I can get the eraser to work. And we need to test these points. So 0, so what we're looking for is anything that's in here is a possible solution. So when they ask us to do this, they're asking us to plot these points. So 0, 1 is on that line. That's a solution. Negative 1, 1 is there. It's not in there. 2, 2, we're good. Negative 2, 2, we're good. 0, 0, no. And negative 2, 1 is a no. And so for this one, once again, we can do the exact same thing. No. Yes, because it's on the line. If it was on a dotted line, it would not be part of the solution. 2, 2, no. Negative 2, 2, no. 0, 0, no. Negative 2, 1, yes. And for this, the equations are the same. This one is a, so for this line here, it is a solid line. But from that line, we are shading down. So that's going to be y is less than or equal to negative 1/3 x plus 1. And from the second line here, we're shading up. So it's going to be y is greater than or equal to, which is that one. Remember, if you ever get confused about shading up or down, just put your pencil on the line and go up. That's shading up. All right. So for part V here, graph this following system of inequalities. So y equals 5x minus 2. So the y-intercept is 2. The slope is 1, 2, 3, 4, 5 over 1. And so we'd have a dotted line like that. And then y is greater than 6x plus negative 6x, so here. And once again, it's a dotted line. Now, from the first equation, we're going to be shading up. No, sorry, from the first equation, which y is less than 5x minus 2, which is this first equation here, we're shading down. So, and then on the second equation, we're shading up. So our answer is this region in here. Oh, hold on one second, I have to take a phone call. And we're back recording. Is now we just check these points. So 0, 0 is not in the shaded area. 0, negative 1 is not in the shaded area. 1, 1 is in the shaded area, and 2, 0 is in the shaded area. All right, so now we're getting into the word problems. Once again, the hardest problem in general with the word problems is setting up the equations. So for number 1, the sum of two numbers is 14, and the difference is 28. What are the two numbers? Well, right away I can see that I'm just going to add the two equations together because the coefficients of the y's are additive opposites, and I'll get 2x equals 42, which I'm going to divide by 2. X is 21. So my first number is 21. So my second number is, if I solve that, is negative 7. I'm not even going to do the second step of the problem for you. But so what number would I have to, well, I can, I guess. So 21 plus y equals 14. Subtract 21 from both sides. Y equals negative 7. All right, for this one, so the AMC Theater charges $11 for adults tickets and $7 for children's tickets. Miss Goody purchased 15 tickets. So A plus C equals 15. And then the price she paid was $11 per adult ticket plus $7 per child ticket for $125. Man, it costs a lot to go to the movies these days. And then you would solve this system. You could use graphing, you could use lots of methods. If your teacher didn't show you this and you have a graphing calculator at home, I'm going to show you another way is if both equations are written in general form, we can use matrices. And if you didn't see this, don't worry about it. You can do it another way. You can do it graphically like you were taught before. There are many, many, many different ways to do this. But if we want to do it using the matrices, what you do is you go to Matrix, Edit, and you put in, oops, sorry, I gotta go close that up. You put in the coefficient of the problem. So 1, 1, 15, 11, 7, 125. And then you quit. Quit. And then we just go to matrices, math, and remember we do the Spanish ref, which is the reroll. They already do the ref, and which is the once again. Messed it up, so we'll start over. We do the math, number, sorry, matrix, math, Spanish ref, and then we go to matrix A. And so there were 5 adult tickets and 10 child tickets. Another way you could do this if you don't know the calculator is you could multiply the entire top equation by 7 and use elimination. For this one, Xboxes plus PS4s was 75. Now here's where people get messed up. If they sold 24 more PS4s, and so what a lot of people try and do is they try and add 23 to the P, but that is incorrect. In order for them to be equal, I need to add the 23 to the X, because we want this equation to balance. Think about the scales. If you put the PS4s on one side and the Xboxes on the other, if you sold more PS4s, in order to balance the scales, you'd have to put the extras on the Xbox scale. And I can solve this using substitution. X plus 23. Why did it stop writing? Uh-oh. Whoa, something went crazy. Well, we'll be back in a second, maybe. Let me pause. We'll pause, and when the computer is uncrashed, I'll be back. All right, we lost all our ink, but that's okay. We'll pick it back up here. Let's just start the problem over. So we had X, smart ink, X plus 75, X plus P equals 75. I don't know what's happening here with my writing. Hopefully it's taken care of. Plus 23 equals P. I think we're okay now. And so we said that we would get, if we use substitution, we get X plus 23 equals 75, or 2X plus 23 equals 75. If you solve that, you get 26 Xboxes and 49 PS4s. For this one, for Maria paid $22.50 to buy 7 student tickets and 2 adult tickets. So that's going to be $22.75. Sam paid, bought 4 student tickets and 1 adult ticket and paid $12.50. So there's your system of equations where S is the price of a student ticket and A is, and if you want to do this using elimination, you would multiply this equation by 2, then the coefficients of the 2 A's would be the same, and you subtract them, and your final answer should have been 3.5 and 2.25. Now we're almost done. So Devin correctly solved a system of linear equations, and the last line of his work was 5 equals 5. What does that mean about the solution to the system? Well, if you wind up with no variables in a true statement, that means there are infinite solutions. If, on the other hand, you wind up with an untrue statement, like 7 does not equal 3, then there would be no solution. This is once again just asking you to solve the equations. Let's multiply. I'll multiply the bottom equation by 3, so I get additive opposite. So I get 2x minus 3y equals negative 2, and then 12x plus 3y, sorry, that's awful, 12x plus 3y equals 72. Then we add the two equations together and I'll get 14x equals 74. Divide both sides by 14. Wait, I made a mistake somewhere. Where did I make my mistake? Oh, sorry. Equals 70 when I add those together. There's my mistake. 70 divided by 14 is 5. So I get x equals 5. But that's not what the question asks. The question asks what is y. And so 4 times 5 plus y equals 24. 20 plus y equals 24. Subtract 20 from both sides. Y equals 4. All right, for C here. At a restaurant, the cost of a breakfast taco and a small milk is $2.10. So and means add and is means equal. The cost for 2 tacos and 3 milks is $5.15. It didn't ask us to solve, it just asked us to write the equation. And for the very last problem here, Molly began by graphing the system of inequalities below. I believe the negative got dropped on your photocopies. We apologize for that. To complete a graph, Molly must shade the parts of the solution. So Molly is going to shade down here from the first equation. And on the second equation, she's going to shade up. And so my solution is the point where the two inequalities intersect, which is this shaded region right in here. If you have any questions about any of these, please come by and ask your teacher. But otherwise, good luck on the exam and have a great day.